All right, so in our properties of water, if we take a look at station number 9. Station number 9, I have some material.
Trying to yodel?
Nope. Set up for us. So we have, I have some beakers. I have a beaker of hot water and some hot metal in there. And I have a beaker of cold water, and the temperatures are displayed up on the screen. Okay, so station number 9 talks about 100 grams of cold water, 100 grams of hot water, 100 grams of hot metal. Okay, and we're going to put them into the things. So, what I'm about to do, so on 9A it says the temperatures, compare the temperatures of the 2 beakers of cold water. I don't have 2 beakers of cold water yet, okay, but they're all going to get poured from this one, okay. Now, blue, I'm telling you, is, the blue number up there is my cold beaker, okay. Now, if I pour water from this beaker into this beaker, and water from this beaker into this beaker, what can we say about the temperatures of these 2 beakers?
It should be the exact same.
Okay, they should be the same starting temperature. So, let's get 100 grams, which is equal to 100 milliliters. Don't want ice, though. Grams, which is also 100 milliliters. All right, so now I'm going to take this one. This is the blue. This is my blue one right here, and that's going to go, the blue's going on my right, which is your left, okay? The green one is going to go over here. So this is green, which should hopefully start dropping here. Well, that's funny. It is dropping on my computer.
Maybe it's
oh, my iPad went to sleep. There we go. Okay, it went to sleep. Okay, so they're getting closer, right? So they're close. We're within 0.4 degrees. Now that could just be the calibration of these, okay? So we're going to say that they're pretty darn close. So we're going to say that my 2 cold beakers are the same. Now what's true about the temperature of this piece of metal and the temperature of this hot water, considering they're in the exact same container? They're both starting at 80 degrees, right? Fair statement? Okay, so they're going to start at 80. I got to make sure I only have 100. Oh, that's okay. So we have 100 grams of water, and this piece of metal is 100 grams as well. So what I'm going to do is I'm going to add 100 grams of hot metal to one, and I'm going to add 100 grams of hot water to the other. Now, before I do this, letter C, predict how the temperatures of the water, how will the temperatures of the water in the beakers compare? Okay, so predict which one do you think is going to be hottest? The one with the hot metal, the one with the hot water, or do you think they're going to be the same? Station 9C, you're making a prediction, which one's going to be hottest? The hot metal beaker, the hot water beaker, or will they be the same temperature? Okay, and I'm going to do this, hopefully, I'm going to do it right now. So hot metal, 100 grams, 100 grams. And you can still be making your prediction while you go. Which one is this one? Is this green or was this red? Is this green or blue?
That one was blue.
This is the blue one. This was the, here. Okay, this is red. Ignore red, we don't care about red anymore. Okay, so we give it some time. This is the blue one. Okay, so the 100 grams of hot metal went from about 6.7 degrees, something like that, 6.4 degrees, up to like 7.6. So it went up about 1 degree. Okay, but when I added 100 grams of hot water, 100 grams of hot metal, 100 grams of hot water, both 100 grams equal mass, The hot water one went up to 37. Okay, so I see 37 for my hot water, and I see 8 for my hot metal. Did both my beakers, cold beakers, start at the same temp? Did my metal and water start at the same temp? But are these temps the same? No, they're very different, right? So one of the properties of water that we discussed yesterday was high specific heat. Okay, and water actually retains a lot of heat, and actually takes a lot of heat to heat up water, same idea. But the hot water one, 37, is dropping a little bit now, was like 37 compared to like 8. We're creeping up to 9 degrees right now in the metal. So it's going up a little bit, but definitely the hot water one, ooh, that was close, I almost spilled it completely. The hot water one definitely raised the starting temperature much higher. Water has a high specific heat value. I thought I was going to ask which property of water. But that's kind of the whole, like I talked yesterday about Seattle having a kind of a buffer, because the ocean's right there. Great Lakes, Mr. DeBoer referenced the Great Lakes. Okay, if you are a city that sits right on the Great Lakes, your temperatures are slightly different than just 10, 20 miles inland. There's a small impact that it does. There's an impact, depends on the wind patterns too, but it does have some impact. Okay, so water has a high specific heat value, and 100 grams of hot water increased your starting temperature quite a bit more than the hot metal. Now, part of why this hot metal one is warming up a little bit too, now we're up to like 10.5, is right now the room is about 20 some degrees Celsius. So just sitting at room temperature, it's gonna warm up a little bit. So that's partially what it is. Actually, it's probably more why it's ticking up a little bit right now, but, okay. So that's station number 9. The rest of these, there's 7 stations still. Oh, we forgot to look at number 8. Let's take a look at number 8. Second period, I have recorded that we started at 960 milliliters of water. Station 8, correct? 8B, what was the level of the liquid? Then you made a prediction whether it would be higher, greater, or less. Somewhere you should probably actually observe what was your prediction correct. So 8D, the actual volume today is 950 milliliters of water. It's 950 milliliters of water. So we started at 960, it's now at 950. So the volume of water went down a little bit, 10 mils, right? Didn't the water evaporate? Do you think water evaporated from this?
No, because you
Yeah.
have the cover on.
Right, we covered it. That was the intent of our cover, was try to eliminate as much evaporation as possible. For the record, 10 milliliters of water. I was gonna grab a graduate soda, but I don't see one. It's quite a bit, right? So 10 grams didn't evaporate overnight. So what happened? Well, the volume went down, but our ice is gone. Okay, now some of my other classes observed that, like when I touched yours yesterday, it was wet. There was condensation on the outside, there was water on the outside. That water that was on my hand, was that water that was once inside my glass cylinder?
No.
Yeah.
And it slowly seeped through the glass, and that's what was getting my hand wet yesterday?
No.
No, that's condensation. And where did that water vapor, or where did that condensation come from that was all over the outside of
Because it
this
was
cold cylinder?
hotter out here than it was inside.
But where did the water that was on my hand come from? Just like right here, okay? There's water on my hand from this cold beaker. Where's this water coming from?
Atmosphere.
From the atmosphere, from the air around us, okay? So that was some observations that my other classes made. Well, there's water on it, but did that water like leak through? No. Okay, so think about station 5, because station number 5 was your water molecule. And when station number 5, when this hydrogen bonding, these models arrange in a pattern, we get some empty space that forms between these molecules. when water freezes, there becomes some empty space freezes, there becomes some empty space between them. So we did, instead of making ice, we melted ice. So that space that was between those molecules should have gotten closer together. Water's a weird one, okay? But when water melted, those molecules actually got closer together, and then, in theory, that should be, I don't want to use the word theory, but that is probably has to do with why it went down. The opposite, I did an opposite experiment, okay? And the opposite experiment we did with a pipe, okay? So, how many of you have ever winterized, or you own something that you have to winterize when it comes time to the winter? Cabin, camper, boat, those are some pretty things.
Some batteries.
Thing, okay, I'm talking about, like water ones.
Oh.
Okay, cabin, campers, boats, those are probably the three common, pressure washers. Okay, why do you have to worry about water in the winter and those things?
Because one, if it seeps in, then when it freezes, it can expand and make like a crack.
Correct.
It's basically the exact same thing as we learned in middle school.
Okay,
When
I'm gonna stop you, thank you.
backfilled.
Yep, you were right, so it's gonna expand. So what I did is I took this pipe, and some people from another class, their minds went to pipe bomb, I don't know why. But I took this pipe and I put a cap on each end and I completely filled it with water. Completely filled it with water. Okay? And then I broke the pipe open using water and water only. What did I do to crack this pipe? I froze it. Yeah, I took this, I threw it in the freezer, and this piece of metal broke off and actually broke off, and when it broke, it busted my bucket. So I'm guessing it came off with some force. But it broke this pipe. Now, it's a pretty solid pipe, and if you want, I'll have it up front. The metal cap is probably, that's about 1/8 inch thick of metal, but it broke it. Okay? So the opposite of true of what we just did is the reverse of it, right? So instead of melting ice and the water molecules got closer together, we pushed them further apart, and it exerted enough pressure that actually cracked this metal pipe. Yeah.
What type of metal are you using for the caps? Is it copper or is it steel?
This is, I'm pretty sure it's cast iron.
Oh, okay.
Yeah, so this is metal, because it was, so this is well, I think they call it black pipe, not galvanized pipe, but they call it black pipe. It's, because it's all rusty, looking at it, I'm guessing it's a cast iron, but it does rust, so it's not brass, it's not copper, I'm pretty sure it's cast iron. So the fact that this cracked, this is why we winterize our boats, this is why we winterize our cabins, this is why we winterize our campers.
Well, even your outside, if you've got an outside faucet at your house, you've been watering the garden or watering the flowers, what do you do when it starts to, well, pretty quick this time of year? You go inside, you turn the water off to the outside, right? You go outside, you open that faucet valve to make sure all the water drains out. Why?
Because if this
Water
was your,
expands.
yeah, if this was your water pipe, let's just pretend this is your water pipe and it froze solid, that's fine. But come spring, when it starts to, well, I shouldn't say it's fine, but you might not know it's broken. Come spring, because now you got like this plug of ice, right? That's kind of plugging the hole, blocking the hole. Come spring, when it starts to melt, what would then potentially start flowing, and it could be filling your walls of your basement with water. Okay? Or it cracks, and then when you turn it on, it floods your basement or your camper, or your cooling system on your boat motor doesn't work anymore, right? So that's why you winterize some stuff. It's the inverse of what we did there. So I want to try to give you as much time as I can. If we have individual questions, I'll answer those once we get you going, because I want to get you guys going again. You have the 7 stations that some of you didn't do the best job of rotating through. Okay, some of them are more fun than the others, I get it. But we want to make sure we get through as many stations as we possibly can. Okay, we're here till 09, so we got about a half hour. We got about a half hour, and that time you should be be able to finish the rest of the 7 stations that you haven't gotten to already. Other things to work on. Tomorrow is your test here in biology. Yesterday you got a study guide. The due date on that study guide is tonight at 11:59 p.m. for you to go through and submit that in Canvas. You took a practice test last week. If you want to take that practice test again because you think it's good for your learning, do it. It's still up, it's still available. If you say, hey, I did even better this time, can I still submit that screenshot? Sure, go ahead. Okay? There's things to do to help you prepare for tomorrow's test, and there's 2 great resources in the room right now for you to ask too. So if you have questions on the study guide, you have questions on the practice test, great opportunity to ask those as well. We got to do a little bit better job of rotating through. Mr. DeBoer and I both counted those water molecules. There's still 20 of them. None of them have evaporated into someone's pocket yet. So we're going to make sure that doesn't happen, and we'll count them again before we leave. Questions, let us know.
Have at her.